Good day friends. Today we are going to discuss about namespaces. Namespaces are predominantly logical areas present in a Kubernetes cluster. Consider that you have a Kubernetes cluster which consists of one masternode and 10 worker nodes. So the customer requested you to deploy their development pods, test pods, and the production pods on the Kubernetes cluster which is presently up and running, so that deploying all the pods in a single Kubernetes cluster will create big mess. Or in other words, it is very difficult for us to segregate it in a systematic manner. Or if we define a roles to the particular resources, like L1 resources would be performing or managing all the development pods, and the L2 resources would be managing the test pods, and the L3 resources would be managing the production pods. So if any of the resource log into the Kubernetes cluster, he would be able to see all the pods if we haven't divided in a logical manner. So the systematic way is we will create a virtual rooms within the cluster. So the advantage is each room we can name it as, one is dev, second is test, and the third is production, so that we will deploy all the development pods in the development room, virtual room. In Kubernetes technical term, it is called as namespace. And all the test pods we will deploy in the test namespace. The same way we will deploy all the production pods in the production namespace. So the advantage here is, only thing we have to enable access to that particular room or to that particular namespace. The resource can only see that particular pods within the room, and the other room, this particular resource will not be accessible. So whenever the L1 resource log into the Kubernetes cluster, he is supposed to manage, or he is supposed to do the transactions on development pods. So whatever the commands he will be parsing, if we try to list all the pods, he will be only able to list the pods pertain to the development namespace. The similar way, L2 resources will be able to list only the test pods, and L3 resources will be able to list only the production pods. That is the concept of a namespace. Again, in this case you may ask whether the pods would be able to communicate together. Are we able to access, or are we able to ping from development namespace to production namespace or test namespace? I would say the answer is yes, because there is kube-proxy service is running within the cluster and within each nodes, so that the routing is being taken care by the respective kube-proxy, so that the ports will be accessible. Again, a specific services, a kind of node port and all, has to be configured separately, but excuse me, the IPs will be pingable and the ports can communicate together. If we wish to stop such communication or restrict such communications. We may have to impose the network policies. That would be a different separate topic we would be discussing later. So now coming into the slide, we have a master node here and 4 worker nodes here. So altogether this is called a Kubernetes cluster. Needless to say, the customer has given us total of 50 pods. So 10 development pods, 10 test pods and 30 production pods. So the first 10 pods can be developed, all the development pods can be placed on the namespace A. The test pods can be placed on the namespace B, and the production pods can be placed on namespace C. Now you will ask one more question, or I may answer one more question here. Is it possible for me to create a namespace exclusively for a physical node? Like development node should development namespace should be on a particular node, and the test namespace should be on a particular particular node, and the production namespace should span across some certain nodes, like this manner. Here the answer is no, because this is just a logical partitioning, and it is impossible for us to define a namespace limit. The Kubernetes cluster, especially the scheduler and the kubelet and API server together decides where, when and where to deploy and how to deploy the pods. The namespace is just for segregating the objectives, I would say objects. If you look at the namespace, a pod, a replicaset, a deployment, a persistent volume claim. Remember, persistent volume claim, services, network policies, and thus many objects can define within the namespace. Remember, persistent volume is not applicable to a particular namespace. If we create a common persistent volume, that can map to any of the namespace in and out, we can do that. That we will discuss during our storage management session. Alright, so that's it regarding the namespace. Let's move on to the lab and practical hands-on scenario here. So this is basically our kubectl get nodes. We have a master and 2 worker nodes. So kubectl get pods. There is no pods present here. Okay. Now kubectl create namespace. I'll create a namespace name called def, then test, then prod. Okay, Now kubectl get ns namespace. If we look at here, we have a namespace called dev, we have a namespace called prod, we have a namespace called test. Now let's create pods on each namespace. Kubectl run, or in this way, kubectl minus n dev hyphen or nginx hyphen image nginx. Excuse me, I'm sorry. Nginx pod is created. We just missed to give that run attributes in that command line. Similarly, kubectl minus n test run redis hyphen image redis. Now kubectl minus n prod, so run. Here we will do one thing, we will create another nginx hyphen image nginx. I'm not sure whether you have look at here. I have created a pod in pod nginx in development namespace, and I have created a pod in production namespace. Both the name is same, so that it is created. Let's look at some other example. Kubectl run nginx hyphen image nginx. This is created in my default namespace. I will try to create once again because it has thrown an error stating the pod is already present, so that we cannot create another one. That's the difference. So those all are virtually divided or logically divided rooms, so that we can create the pods on particular namespace. Now we have another task here. How do we see that? Kubectl get pods minus n def. Yes, it's up and running. Minus o wide. It's up and running. Fine. Now let's do this exercise. Kubectl run alpine. Alpine is a pod which is the beauty here is Alpine is having ping utility, so that we can ping to each and every pod from the particular namespace, so that we can make sure that it is able to communicate together. So hyphen image Alpine, so minus it is for interactive terminal minus n test namespace. So I'll do one thing, restart equal to never. hyphen sh. So what it will do is, I'll tell you that hyphen restart equal to never means if there is any crash or some error has happened, this pod will try to restart it, or if we assign some specific task to this pod, once the task is completed it will try to restart it. So we don't want to do that, so that's the reason I put it this way. And hyphen sh means I will land into a shell prompt. Let's see that. Remember that I'm in test namespace. So from here we will ping so from a test namespace I am able to ping to the development namespace. That means I do not have any. Let me try whether traceroute utility is there or not. I'm not sure whether. Yes, it is there. So guys, if you look at it, so 10.5.1.1 is our around minus n. If you look at it, this is my base machine, I mean the pod, Alpine pod, which we downloaded, and our IP is our IP is 10.5.1.10 and 10.5.1.10 is our IP address, and this IP address is communicating to the gateway 10.5.1.1. This is it's just like a virtual Ethernet switch present in the respective kube-proxy layer. Okay, kube-proxy layer, remember that. Same way this 10.5.1.1 is bound to the base machine 192.168.0.31. So this is our base machine. So from there it will go back to the other pod, which is 10.5.2.6, which is the Nginx. Now let's look at it. kubectl minus n test get pods minus o wide. It is hosted on node 2. Now let's look at it. Where is that hosted? Nginx is hosted at node 3. That means my pod has to go to the virtual Ethernet card and card connected in this server. I mean it is in the kube-proxy layer. From kube-proxy it will connect to the base machine of the base machine's network card or that particular IP, that taken it as a gateway for accessing the outside. So through that gateway it has reached out to the node 3's, the pod hosted on the node 3. Hope it is clear. We will discuss more during the networking session. We have couple more things because especially for explaining the network security we have to be on same page in networking. So we'll discuss that. So just understand now this way. So the communications will happen, but the properties we cannot see it. Now before let you go, let me show you some more couple more points. That is, now I have kubectl get ns. So we have this many namespace. So I have a default namespace and this many other namespaces are available. I just want to create a kubectl config set -context -current -namespace equal to let's do def. Now the existing context, I mean my default namespace has been changed to def. Now it is as simple as kubectl get parts. Sorry, I'm able to see it. In a similar way, if I change again just test, I'll get the test as my default namespace. What is happening here is, it is very simple. There's not much rocket science here. We have a profile file within the user home directory. So that is cd.kube so it is okay, cd.kube within my home directory. If we go there, we can see that a config file, cat config. If you look at here, it is just like our dot profile, bash profile or bash rc file. Some parameters we have mentioned here. That is as simple as like that only. So here we have mentioned our namespace as test. If I update here it as protection, let me update it. I don't need to go through all these commands and all. It is as simple as I can just edit this file. No need to run that command. That's it. See, that's it. So we are at the production namespace. So hope you are very clear on this part. So that's it about the namespace. We will come up with more sessions regarding the volumes and persistent volume claims. And in the volume itself we have a couple of parts like a static volume and dynamic volume. So we will discuss about all those things. Once these basic scenarios are completed, then we will start the CI/CD pipelines and hosting Kubernetes on the Google Cloud platform as well as AWS. Thank you guys for your time, and it would be great if you can share your valuable feedback so that we can improve ourselves